is not equal, and because of that we can say these two IP addresses is not residing in one range. Because of that, this default gateway cannot be useful for sending traffic to the outside of the network. You can use this method, okay, determining IP address within a subnet mask, within a subnet, okay. Or maybe if you want to convert the IP address to binary format, and after that find that the default gateway is residing in our network. For example, with this IP address, you can use one of the IP address in the, for example, range between 10.1.164 to 10.1.127 as a default gateway. Let me to show you when we have this IP address in the PC1, we cannot send traffic to the outside of the network. Okay, this is our scenario. I'm going to change the IP address of the PC1 to 10.1.117. Okay, for example, this is the PC1, and here we can change the IP address from 10.1.1.10 to the 10.1.1, for example, 70. Let me to change it. Okay, after that, okay, now we will receive one error message. Look at here. Okay, warning, the default gateway is not on the same network segment subnet that is defined by the IP address and subnet mask. Do you want to save this configuration? Yes. Okay, then close. Now let me to show you what is happening when we are trying to send traffic to the outside of the network. You know that the default gateway is not accessible now. As you can see, ping 10.1.1.1, the default gateway is not accessible. Actually, we can say that we don't have any communication with the outside of the network. For example, ping 192.0.2.10. Okay, we don't have connectivity. Now let me to solve the problem again. From here we need to first, you can use, for example, ipconfig to find the reason of the problem, the root of the problem. ipconfig, again, useful command. 10.1.1.17, and after that 10.1.1.1, it is not okay. After that you can change it in the for example TCP IP 10.1.1. Then for example, let me to use the 10 again, and everything is okay now. After that, okay, after that this, and then look at here, ping 10.1.1, for example 1. Now we have connectivity to the gateway, and also we will have connectivity to the for example outside of the network 192.0.2.1. okay, we have connectivity. Okay, because of that we can use ipconfig for finding the IP address, for finding the subnet mask, default gateway, and also we can use show IP interface, then the interface name in the router for verifying the status, the IP address, and the subnet mask of the router. I know that all of the features that I have talked about them in this video until now about the IPv4 addressing was experienced in the CCNA class. It's okay, but now we can better understand the importance of the correct IP address, the importance of the correct subnet mask, and also correct default gateway. And you know that one of the for example features that one administrator should have, okay, is the troubleshooting skills. About the troubleshooting skills, you need the knowledge first. After that you need to have experience. Because of that, with the knowledge and experience, finally you will be a master in the network creating, network designing, network implementing, and also network troubleshooting. Because of that, it is so important to think the features that you know with more detail. Okay, not only, for example, the IP address itself, subnet mask itself, and default gateway itself. You should think about the combination of these features beside of each other. And for example, you need to have more skill with practicing, with, for example, solving scenarios in the emulators or maybe in the real networks. Very good. Until now, we have learned about the IPv4 addressing, and this is the fundamental topic for the ENARSI. Okay, in the next section, I'm going to review some of the features related to the DHCP or dynamic host configuration for IPv4. In this section, I'm going to review the concept of DHCP for IPv4. DHCP is the abbreviation of the Dynamic Host Configuration Protocol, and you know that we can use DHCP for IP address assignment or some other important addressing, for example, to the clients. In one networks, for example, maybe we have more than 10, 100 or maybe more PC and host, and we cannot assign each of these systems manually IP address. This is an error prone function, and also it has overhead of administration. Because of that, in most cases we are using the DHCP services. We have in our company one or more DHCP server, and each PC after boot should find the DHCP server, and DHCP server can assign from its pool IP address to the PCs, and also some other useful information, for example the address of the default gateway, the address of the DNS server, or some other addressing that we are using in our network. Actually, we can say that when a DHCP client initially boots, it has no IP address, no default gateway, and such a useful information, for example DNS services, okay, addressing. And after the way a DHCP client initially communicates is by sending a broadcast message, that is the DHCP discover message. You know that when the PC1 is booting, okay, it should find first the DHCP server, but it doesn't have any IP address. How we can find the DHCP server without any address? Okay, we are sending one broadcast message. The name of this broadcast message is DHCP discovery. DHCP discovery is sent to the for example quad 255, the broadcast address, and because of that all of the systems in our network can receive this DHCP discovery, but only the DHCP should answer to the DHCP discovery, because you know that in DHCP we are using UDP, okay, port of 67 and also 68. 67 is the port of server and 68 is the port of client, because the destination port of this DHCP discovery is the UDP 67. Only the DHCP services or the DHCP server should answer to the DHCP discovery. Okay, after DHCP discovery, the DHCP server can give some addressing to the as in the DHCP offer to the client. For example, here we have some useful information about the IP addressing, subnet mask, the address of the default gateway, address of the DNS server, or some other useful information. Okay, you know that until now we don't have any IP address in the for example PC. Because of that, all of this DHCP process should be done with the broadcast message, because the DHCP client until now does not have any IP address. And after that, because this is broadcast, maybe other systems in the network are for example receiving this broadcast. It is not important. The only the client that advertised this DHCP discovery can accept this information. Look at here. Maybe in our company we have more than one DHCP server, because we are sending DHCP discovery in broadcast. Multiple DHCP server can receive this DHCP discovery, and all of them can send us DHCP offer. In most cases, the DHCP client should choose one of them, and the one that is sending the first DHCP offer in most cases is choosing. Okay, after that we should send the DHCP request to the server that we want to take IP address or some other information from that server, again with broadcast. Why? Because you know that until now we don't have any IP address. After that, DHCP can bind our information or for example MAC address to the IP address, and after that it can give DHCP it can give us DHCP acknowledgement, and after that we will have the IP address. Actually, we can say the taking IP address from the DHCP server is a 4-step process. First, we are sending DHCP discovery. DHCP server can send DHCP offer to the client. Then DHCP request should be sent from the DHCP client to DHCP server. And finally, we will receive DHCP acknowledgement. Let me to show you this overall process in this scenario. After that, we can, for example, verify our information